last tutorial was solving systems of linear equations using substitution. This will be solving two systems of two linear equations using elimination. So if we look at a system of linear equations, maybe y is equal to 2x minus 5 and y is equal to 3x plus 1. And we want to know where these two lines intersect. Well, there's really three ways to do it. The first way is just to graph these two lines and see where they cross. That's not always the best way though, because sometimes their intersection is not a lattice point and it's not so easy to guess it correctly. So there's also substitution, which we could substitute 3x plus 1 right in here for y and solve for x. But this third method is called elimination, and what elimination does is it eliminates one of the variables. So what I do is take this first equation and then I subtract the second equation from this first one. So subtract this equation from this one. Sometimes it's in our best interest to add equations, but here we're going to subtract because when we do, we get y minus y, which is 0. And so that eliminates that variable, which is why it's called elimination. So this is equal to, what's 2x minus 3x? That's negative x. And then I have negative 5 minus 1. Negative 5 minus 1 is negative 6. So now I get this brand new equation here. And to solve it, we should just, we can multiply both sides by negative 1 to get 0 is equal to x plus 6. And then subtract 6 from both sides to get x is equal to negative 6. Once I have x is equal to negative 6, I can just plug it in for either one of these equations to get the y value. So the y value is 2 times negative 6 minus 5, which is negative 12. Negative 12 minus 5 is negative 17. So the solution to this equation is negative 6, negative 17. Okay, so that's sort of an easy-ish example. It can be more difficult if we have to do some work to eliminate a variable. So what if our system instead said something like 2x plus 3y is equal to 5 and 5x minus 4y is equal to 10, something like this. Well, we can't just subtract equations at this point or add equations at this point, because if we do, no elimination is going to occur. If you subtract equations, for instance, you'll have 2x minus 5x is negative 3x. You'll have negative 3x plus 7x is equal to negative 5, plus 7y is equal to negative 5. That doesn't eliminate anything. So what you have to do is multiply through by a non-zero constant to force coefficients of one of the variables to be the same. For instance, if I wanted to eliminate the x's in this case, I would need the coefficients of both of these x's to be the same number. That's going to call for us to multiply this top equation by 5 and the bottom equation by 2, because when I do that, the coefficient on the x's will both be 10. So I'll get this new system, which is an equivalent system, by the way, which is 10x plus 15y is equal to 25. The second equation will be 10x minus 8y is equal to 20. Now we have an equivalent system, and this time the x's have the same coefficient. So now we can do that subtraction. We're going to subtract the second equation from the first. By the way, I always recommend putting parentheses around this second equation so that you remember to carry that minus sign through, okay? So 10x minus 10x is 0. We've successfully eliminated those x's. I've got 15y minus negative 8y is 23y. And then I have 25 minus 20 is 5, which means my y value is 5 over 23. Now I have to solve for x. So to solve for x, I can just go right back to one of these two equations here. It doesn't matter which one. and plug in the y value. So let's just go to this first equation here. I have 2 times x plus 3 times 5/23 is the y value. This has to be equal to 5. So I have 2x plus 15/23 is equal to 5. I should subtract 15/23 from both sides. So I have 2x. 2x is equal to 5 minus 15/23. Okay, so I have to get a common denominator at this point. So if I multiply the 5 top and bottom by 23, what do I get? 115 over 23, I think? I hope. 5 times 20 is 100. 5 times, yeah, that's right. This is minus 15/23. So I get 2x is equal to 100 over 23. So 2x is equal to 100 over 23. And then divide both sides by 2. This tells me that x is equal to 100 divided by 46, which is 50 over 23. So that's the x value, 50 over 23. And the y value is 5 over 23. So the solution is the point 50 over 23, comma 5 over 23. And that's the point at which these two lines intersect, assuming I didn't make any arithmetic mistakes, which I don't think I did. So, yeah, so this is the third method, which is called elimination. And we call it elimination because the goal is to eliminate one of the variables, which we did at this step here. I hope this helps. I hope you enjoy solving your systems using elimination. Have fun.